Look at how far we've come. From the Radeon HD 3870 launched back in 2007 to the RX 480, a ton has changed. AMD is using a manufacturing process 4 nodes smaller. The current King has double the PCIe bandwidth, up to 16 times the video frame buffer size, support for DirectX 12 and Vulkan versus DX 10.1, and it actually costs less. So let's take a look at AMD video card innovation over the last 10 years and see how it is that we got here. The Master Keys Pro keyboard lineup from Cooler Master is available in 3 sizes, each in white or RGB flavors. Check them out at the link below. We already had quite a few of the representatives we needed of AMD's top single GPU graphics card for each generation. But there were a few codename XT cards missing from our Pokédex. So this project began, as so many seem to have lately, with eBay.ca, because Canadians don't get the good eBay. For our test, we went with a high-end modern test bench to avoid bottlenecks, and we ran a mix of synthetic benchmarks and games, both modern and, kills me to think of things I played as a teenager as classic or retro, but we've got some of that too. First up is the Radeon HD 3870. This was truly a dark time for the AMD rebellion. Their previous generation flagship 2900 XT, with its groundbreaking but very expensive 512-bit memory bus, had just gotten its butt soundly kicked by NVIDIA's G80. So it was time for a strategy shift. Instead of building a huge, complex GPU, AMD built a smaller, more efficient one, relying on Crossfire technology to reach the high-end enthusiast market. Thanks to being built on a 55 versus 80 nanometer process, the 3870 managed to perform similarly while being much cheaper than its predecessor. AMD looked to build on the success of that lower performance but lower risk strategy with the 4870. Codename RV770 XT was a substantially larger chip than the 3870 at 256mm squared, but that extra performance and frame buffer sizes up to 2 gigs allowed AMD to command a higher price. And that's still just over half the size of their last attempt at a big GPU. The Radeon HD 5870 marked a return to confidence for AMD. With over 2 billion transistors, a move from their Terascale to Terascale 2 architecture, bringing with it DirectX 11 support, implementation of PCIe Gen 2.1, and a process shrink from 55 nanometer to 40 nanometer, it was an ambitious project. Not to mention that this was the beginning of AMD's push for multi-display gaming technology that they called Eyefinity. 5870 performed very well against NVIDIA's furnace of a GTX 480 and still holds up well enough today that it might be worth modding your cooler if your fan dies. The HD 6970 built on this success again. AMD officially dubbed its architecture Terascale 3, but due to TSMC's canceled 32 nanometer node, it was actually built on the same 40 nanometer manufacturing process. So performance wasn't dramatically better, with die size, transistor count, and notably power consumption all rising substantially. That last in particular was a trend that just couldn't continue indefinitely. The HD 7970 was another huge undertaking. AMD went from 2.64 to over 4 billion transistors with a wide 384-bit memory interface. They moved to the 28 nanometer manufacturing process. They added support for PCI Express Gen 3, to the amusement of enthusiasts who noted that AMD motherboard chipsets didn't, and up until very recently still didn't, have official support for it, and introduced the world to the DirectX 12 and Vulkan-compatible GCN architecture that has been the beating heart of every AMD card and APU since. Not to mention the current gen game consoles from all three of the big players. Its compelling performance and forward-looking feature set ended up saving AMD a lot of R&D money in subsequent years. The 7970 was introduced as a top-of-the-line card, but would end up being recycled twice as the 7970 GHz edition and 280X, in lieu of developing new GPUs to compete with NVIDIA's step-down 700 series cards. The Radeon HD 290X that came next was a formal return in many ways to the home run swing strategy that had ultimately let AMD down over half a decade prior. It was huge, slightly larger than the 2900 XT. It rocked over 6 billion transistors, it had a 512-bit memory bus, again, and ran an upgraded version of GCN dubbed GCN 2nd Gen, which all sounds great on paper, but it was damn near impossible to manufacture at a reasonable cost. It ran hotter than summer on the tropical island where they hosted the launch event, and sounded like the jet that I flew there on. Its killer features, Mantle, and True Audio were absorbed or ignored, and it took over a year of driver development to reach its full potential. At which time, AMD promptly relaunched it as 390X. They called it Granada XT instead of Hawaii XT, and claimed to have tweaked it, but evidence for actual changes to the hardware, beyond the availability of higher density memory chips that enabled it to ship with 8 gigs of VRAM, and small process improvements at the chip fab level to achieve slightly higher rated clock speeds, has never materialized. R9 Fury X, on the other hand, was not a rebadge for sure. This thing made Hawaii and Granada look like toys. It introduced a new generation of GCN with a high-quality video scaler and lossless delta color compression. It was the first GPU to use HBM, or high bandwidth memory, which is high performance 3D stacked DRAM, right next to the GPU for a marketed 4096-bit memory interface, and boasted a completely ludicrous 596mm square die with just shy of 9 billion transistors. I mean, I don't blame them. You gotta do what you gotta do to appease PCMR's insatiable lust for frame rates. And the GPU industry had been stuck with 28nm manufacturing for well over 3 years. But when your flagship graphics card needs a pre-packaged water cooler, it might be time to take your foot off the gas pedal. Which is exactly what they did. Just over 4 years later, AMD came full circle, abandoning the revolutionary new features of their previous flagship in favor of something a little more practical. If Fury X was a Ferrari, then RX 480 is an EcoBoost Mustang. I mean, sure, it's not as fast, but it consumes just over half as much power, is available with up to double the VRAM, since unlike HBM, GDDR5 is available on the cheap, does this with a die size that's less than half, partially thanks to a shiny new 14nm manufacturing process, and, oh, did I mention, it's less than a third of the price. Though with all that said, I wouldn't count out AMD as a high-end competitor just yet. They played it safe this generation by launching the sweet spot GPU first, but we've seen working high-end hardware, and Vega is coming. Thanks for watching AMD GPUs Through the Ages. You can check out our previous episodes on Intel CPUs and water blocks, which we'll have hopefully over there. And you can leave a comment if you have suggestions for future follow-ups. Are you a freelancer or small business owner and looking for a way to be more productive, more organized, and get paid faster? FreshBooks could have the solution for you. It's a cloud-based accounting software that is designed for people who are experts at masonry or teaching dance lessons or fixing people's plumbing, but not necessarily experts at accounting. So through FreshBooks, you can send professional-looking invoices in minutes. You can see if your client has seen your invoice. You can get paid on your terms up to 4 days faster. You can take deposits, and you can track things like your hours and expenses, making you come across more professional and making it so that you have more time to focus on the business part of your business instead of the sitting around doing paperwork part of your business. So head over to freshbooks.com/techtips and enter Linus Tech Tips in the How Did You Hear About Us section to try it for free. Thanks for watching, guys. Dislike or like, get subscribed, go do it. And also, if you really like the video, check out the link in the video description to where to buy the stuff we featured, our merch store, and our community forum, which you should totally join.